Imagine you're hiking through the desert at dusk. The sun has just dropped below the horizon. The air is still warm, and you reach down to grab your boot before pulling it on. And there it is, curled inside the toe of your shoe, barely the size of your thumb, is one of the most venomous creatures on the planet, a pale yellow deathstalker scorpion. It doesn't move. It doesn't make a sound. It simply waits. And in that single moment, before you even realize what's happening, your entire life could change forever. Scorpions don't just exist on the fringes of the natural world. They rule it. They have been ruling it for longer than you can possibly comprehend. And today, we are going to go deep, deeper than any casual nature documentary has ever taken you, into the world of the scorpion. By the end of this video, you'll never look at these creatures the same way again. I promise you that. But before we go any further, if you're new here and this kind of mind-bending, deep dive wildlife content is your thing, hit that subscribe button right now. We drop videos exactly like this one regularly, and you do not want to miss what's coming next. Now, let's talk scorpions. Most people think of scorpions as desert creatures, products of the heat, adapted to the sand. But the truth is so much stranger and older and more terrifying than that. Scorpions have been on this earth for approximately 430 to 450 million years. Let that sink in for a second. When scorpions first appeared, there were no dinosaurs. There were no birds. There were no mammals. The continents as we know them didn't even exist yet. Scorpions watched Pangea break apart. They survived the asteroid that wiped out the dinosaurs. They survived multiple mass extinction events that erased the majority of all life on Earth. And here they are today, virtually unchanged, like a biological time capsule walking across your bathroom floor. The earliest scorpions were actually aquatic. They lived in ancient oceans and shallow seas, breathing through gills. At some point, hundreds of millions of years ago, they crawled out of the water and onto land, and never looked back. This wasn't a slow, uncertain transition. Scorpions conquered the land with ruthless efficiency, and they've been perfecting the art of survival ever since. Today, there are roughly 2,500 known species of scorpions found on every continent except Antarctica. You'll find them in the freezing Himalayas, in tropical rainforests, in the caves of Central Europe, and yes, most abundantly, in the world's great deserts. They are extraordinarily adaptable, which is part of what makes them so fascinating and so dangerous. Now, let's talk about venom, because this is where most people's knowledge about scorpions starts and stops. The common belief is that scorpions are deadly, all of them, universally terrifying, instant kill machines. The reality is more nuanced and in some ways, even scarier. Of the roughly 2,500 species of scorpions on Earth, only about 25 to 30 are capable of killing a healthy adult human being. But those 25 to 30 species are absolutely no joke. The most dangerous scorpion in the world is the deathstalker, Liurus quinquestriatus. It lives across North Africa and the Middle East, and its venom is a cocktail of neurotoxins so powerful that they can cause respiratory failure, cardiac arrest, and death within hours. The deathstalker is not large. It's not dramatically colored. It looks almost unassuming, pale yellow, slender, maybe 7 to 10 centimeters long. And yet it is responsible for the majority of scorpion-related deaths worldwide. Children and the elderly are at the highest risk. In some rural regions of North Africa, deathstalker stings are a genuine, everyday public health crisis. But here's something that will blow your mind. That same venom that can kill you? Scientists are studying it right now as a potential treatment for brain cancer. A compound called chlorotoxin, found in deathstalker venom, appears to bind selectively to malignant brain tumor cells and not to healthy tissue. Researchers are testing ways to attach radioactive particles to this compound to create a kind of guided missile that seeks out cancer cells and destroys them. The world's deadliest scorpion might one day save your life. The fat-tailed scorpion of North Africa, Androctonus australis, is another one you need to know about. Its name, Androctonus, literally means man-killer in Greek. The ancient Greeks were not being dramatic. This species produces venom that rivals the deadliest snake venoms in terms of raw toxicity. And unlike many dangerous animals that are shy or elusive, the fat-tailed scorpion is aggressive. It doesn't wait to be provoked. It will sting you preemptively if it feels you are too close. In areas of Morocco and Algeria, This animal is considered more dangerous than any local snake species. And then there's the Indian red scorpion, Hottentotta tamulus, often cited as the most lethal scorpion species in the world on a per-sting basis. The venom triggers a cascade of cardiovascular and pulmonary effects that can kill within 24 hours, and in some Indian villages, the mortality rate for stings, particularly in children, has historically been extremely high. What makes this animal extra terrifying is how common it is. It lives in densely populated areas and regularly enters homes. Now, venom is the scorpion's most famous weapon, but it is far from the only one. Let's talk about how scorpions actually hunt, because the way they do it is deeply unsettling. Scorpions are ambush predators. They are extraordinarily patient. A scorpion may spend hours, sometimes an entire night, almost completely motionless, waiting for prey to wander within range. They don't chase. They don't stalk at distance. They wait, and they wait, and they wait, and then they strike with explosive, almost mechanical precision. They feel the world through vibration. Scorpions have specialized organs called slit sensilla on their legs that can detect ground vibrations so subtle that they can sense a cricket walking several centimeters away in total darkness. They have another organ called the pectins, a pair of comb-like structures on their underside, that are essentially ultra-sensitive chemosensory organs. They drag these pectins along the ground as they move, tasting and smelling the world below them, reading chemical signatures the way we read text. And for all their reputation as venomous killers, scorpions don't always use their venom when they hunt. Venom is metabolically expensive to produce. Many scorpions will grab small prey, insects, spiders, the occasional worm, with their powerful claws, called pedipalps, and simply crush the life out of them mechanically. No venom needed. They save the venom for larger, more dangerous prey, or for situations where they feel genuinely threatened. When they do sting, the delivery is incredibly fast. The tail, technically called the metasoma, curls forward over the body in a fraction of a second. The stinger, called the telson, punches into the target and injects venom with muscular force. The whole motion is nearly too fast to see with the naked eye. And after the prey is subdued, the scorpion doesn't swallow it whole. It uses its chelicerae, small claw-like mouth parts, to tear the prey apart, while secreting digestive enzymes from its gut that begin liquefying the meal outside the body. Scorpions essentially pre-digest their food before consuming it. They drink their meals. Let's talk about something that makes scorpions genuinely eerie in a way that almost feels supernatural. Scorpions glow under ultraviolet light, bright, electric blue-green, like something out of a science fiction film. Take a UV flashlight into a desert night, sweep it across the sand, and suddenly the darkness is filled with ghostly glowing shapes that weren't visible a second before. This phenomenon happens because scorpions have compounds in their exoskeleton, primarily in a layer called the hyaline layer of the cuticle that fluoresces under UV radiation. Beta-carboline and 4-methylcoumarin are among the substances responsible. Scientists have known about this since the 1950s, and they still don't fully understand why it happens or what evolutionary purpose it serves. Some researchers have suggested that the glow might function as a kind of photon collection system, helping scorpions detect even very low levels of moonlight or starlight to assess whether it's dark enough to emerge safely from their burrows. Others think it might help scorpions detect each other, since their eyes can actually see the UV range that causes their own fluorescence. There's even a hypothesis that the glow is a byproduct of some other biological function entirely, a beautiful accident of biochemistry. Whatever the reason, it is one of the most visually striking things you will ever see in the natural world. And while we're talking about strange biological abilities, scorpions can slow their metabolism down to an almost unbelievable degree. In lab conditions, researchers have frozen scorpions completely solid, encased in a block of ice, then thawed them out and watched them walk away. They can survive weeks without food or water in extreme conditions. Some studies suggest that a scorpion could survive on a single insect meal for an entire year, slowing its body's energy consumption to a near standstill when resources are scarce. In the deserts where they live, water conservation is a matter of life and death. Scorpions have evolved a cuticle, the outer shell of their body, that is exceptionally impermeable to water loss. Where other arthropods lose significant moisture through their exoskeleton, scorpions retain it with remarkable efficiency. Some species in the driest environments on Earth have waxy, almost waterproof coatings on their outer body that reduce water loss to nearly zero. They breathe through small openings on their underside called book lungs, named for their layered, page-like internal structure. And they can close those openings almost completely when air conditions are too dry or too hot, essentially holding their breath for extended periods to conserve moisture. In the Atacama Desert, in the Sahara, in the desolate salt flats of Iran, scorpions are living in conditions that would kill most complex life forms within hours. And they are thriving. The size range across scorpion species is something that deserves its own conversation. At one end of the spectrum, you have Microtidius minimus, a species from the Caribbean, which measures barely 1.2 centimeters fully grown. It is so small that it could rest on your thumbnail with room to spare. And it is still a fully functional scorpion, with venom and everything. At the other end, you have the emperor scorpion, Pandinus imperator, from the rainforests of West Africa. This animal can reach 20 to 23 centimeters in length and weigh over 30 grams. It is enormous by any standard, a truly prehistoric-looking creature with massive black claws that look like they belong on something far larger. And here's the twist. The emperor scorpion, despite being one of the largest scorpions on Earth, has relatively mild venom. It is not particularly dangerous to humans. It relies more on its sheer physical power, those crushing claws, to subdue prey. This is actually a pattern in scorpions. Big claws often correlate with weaker venom, and small claws often mean stronger venom. The logic is simple. If you can crush your prey mechanically, you don't need chemical weapons. But if you are small and your claws are delicate and underpowered, you need a chemical backup system that is absolutely devastating. There are strange species on the edges of the scorpion world that will make your head spin. The flat rock scorpion, Hatagenes troglodytes, from southern Africa, is the longest scorpion species in the world, capable of reaching nearly 21 centimeters, and has a body so flattened that it can squeeze into cracks in rock faces less than a few millimeters wide. It is essentially two-dimensional. It flows into rock like liquid. The burrowing scorpion species of the American Southwest can dig tunnels a meter or more straight down into the earth, constructing elaborate underground retreats to escape the surface heat. Some species live their entire lives underground, emerging only to hunt on cooler nights. There are cave-dwelling scorpions that have evolved to be completely blind over millions of years. Eyes are expensive to maintain biologically if you never use them, so evolution stripped them away. These cave scorpions navigate through pure vibration and chemical sensing, moving through total darkness with confidence that most sighted creatures could never manage. Now, let's talk about something that will genuinely disturb you. Cannibalism. Scorpions eat each other, and they do it without hesitation, without apparent reluctance, in a variety of circumstances that reveal just how coldly pragmatic the scorpion world is. Adult scorpions will readily eat smaller scorpions of their own species. Females will sometimes eat males during or after mating. Larger individuals consume smaller ones during food shortages. And perhaps most startlingly, mother scorpions will sometimes eat their own young if resources are critically scarce. Scorpion morality, if we can call it that, is strictly economical. Survival trumps everything else, including kinship. But here's where the scorpion world gives us something remarkable and almost tender: the way females care for their young. Scorpions are viviparous, meaning most species give birth to live young rather than laying eggs. The gestation period can last anywhere from a few months to over a year, depending on the species. And when the babies, called scorplings, are finally born, they climb immediately onto their mother's back. The mother carries them there, dozens of tiny pale white scorplings clinging to her back, sometimes in multiple overlapping layers, until they have gone through their first molt and shed their soft exoskeleton. The mother is extraordinarily protective during this period. She will not feed, she will not leave shelter unnecessarily, and she will aggressively defend her young against any threat. If a scorpling falls off her back, she will pause and allow it to climb back up. The image of a female scorpion with her back covered in babies is one of the most surprising and strangely moving things in the insect world, proof that even in the most ruthless of animal families, parental care can be fierce and devoted. After the first molt, the scorpions become independent. They disperse, find their own territories, and the cycle begins again. Juvenile scorpions molt multiple times as they grow, usually between 5 and 7 times, before reaching adulthood. After each molt, the new exoskeleton is pale and soft and vulnerable, and the scorpion is essentially helpless for a period of hours until the new cuticle hardens. These post-molt windows are the most dangerous moments in a young scorpion's life. Scorpions live surprisingly long lives for arachnids. Many species live between 5 and 8 years in the wild. Emperor scorpions in captivity have reportedly lived to 15 years or more. For a creature without a vertebral column, without warm blood, without the complex social structures we associate with long-lived animals, 15 years is an astonishing lifespan. Let's tackle the myths. Because there are some genuinely widespread pieces of scorpion mythology that simply aren't true, and they're worth dismantling. The most persistent myth is that all scorpions are deadly. As we've already covered, the vast majority of the world's scorpion species are not medically significant to healthy adult humans. A sting from most scorpions will produce pain, localized swelling, maybe some temporary numbness, but not death, not even a hospital visit for most healthy adults. The truly dangerous species are a small minority, concentrated in specific regions. The second myth is that scorpions are insects. They are not. They are arachnids, the same class as spiders, ticks, and mites. They have 8 legs, 2-part bodies, and no antennae. They are more closely related to horseshoe crabs than to any insect. Third myth: scorpions will sting themselves to death if surrounded by fire. This is simply not true. Scorpions are actually largely immune to their own venom. Most species cannot be killed by their own toxin. The image of a scorpion stinging itself surrounded by flames is a dramatic fiction. What actually happens when a scorpion is exposed to extreme heat is that it goes into convulsions due to the heat itself. This muscular spasm can cause the tail to curl and appear to sting, but the scorpion is dying from the heat, not from self-inflicted venom. Now let's talk about human encounters, because these are some of the most intense and occasionally terrifying stories in the natural world. In Arizona alone, which is home to the bark scorpion, Centauroides sculpturatus, the only scorpion in the United States considered medically significant, tens of thousands of people are stung every year. The bark scorpion is a climber, which makes it unusual among scorpions and makes it especially intrusive. It can walk across walls and ceilings. It gets into homes with ease, hides in clothes, crawls into beds, hides in shoes, in folded towels, inside cardboard boxes. Children in southern Arizona grow up learning to shake out their shoes before putting them on. It is a cultural adaptation born from real risk. The venom of the bark scorpion causes intense burning pain, numbness, and in severe cases, particularly in children and the elderly, difficulty swallowing, blurred vision, muscle twitching, and respiratory distress. Before the development of antivenom in the 1990s, bark scorpion stings were a genuine cause of child mortality in the American Southwest. In Mexico, the situation is more serious. Mexico has numerous species of Centauroid scorpions, many more potent than the Arizona bark scorpion, and scorpion stings send hundreds of thousands of people to emergency rooms every year. The Mexican government has invested heavily in antivenom production as a matter of public health. Rural areas where antivenom access is limited see significantly higher mortality rates. In India, an estimated 1.2 million scorpion stings occur every year, with thousands of deaths. In sub-Saharan Africa, in the Middle East, in parts of South America, scorpions are not an exotic fear. They are a daily reality of life. And yet, and this is genuinely humbling, despite living in such close proximity to humans for so long, scorpions have something to teach us that we are only beginning to understand. Scorpion venom, in its full complexity, is one of the most pharmacologically rich substances on Earth. Researchers have identified compounds in various scorpion venoms that show promise for treating autoimmune diseases, pain disorders, bacterial infections, including antibiotic-resistant bacteria, and as we mentioned, certain cancers. The very toxins that have caused human suffering for millennia may ultimately save many more lives than they have ever taken. There's something poetic about that. One of Earth's oldest predators, perfecting its chemical arsenal for hundreds of millions of years, now providing blueprints for the future of medicine. Let's end with a thought that might keep you up tonight. Scientists estimate that there could be between 1,500 and 2,000 species of scorpions that we haven't discovered yet. Remote deserts, deep cave systems, isolated island ecosystems. There are scorpions in places we haven't looked, doing things we can't yet imagine. The scorpion family is almost certainly larger and more diverse than we currently know. There are almost certainly species out there with venoms unlike anything we've analyzed, with behaviors we've never observed, with biological adaptations that would challenge everything we think we know about what is possible for a living creature. 430 million years of evolution. A body plan so efficient that it barely needed to change. A chemical weapon system so sophisticated that it defeats our best antibiotics and inspires our cancer researchers. A level of hardiness so extreme that it can survive nuclear test sites. Yes, scorpions were famously found alive in areas near nuclear test sites in the Nevada desert following detonations in the 1950s, surviving radiation levels that would have been lethal to virtually every other complex organism. The next time you shake out your shoe before putting it on. The next time you feel that instinctive, primal hesitation before reaching under a rock or into a dark corner. Trust that instinct. It is ancient, it is deeply human, and it is the appropriate response to a creature that has been surviving, thriving, and outlasting everything else on this planet for almost 500 million years. Scorpions were here before us. And if something comes along that finally ends the human experiment on Earth, the way the asteroid ended the dinosaurs, I have a feeling we'll know who's still going to be walking across the dust when the dust finally settles. If you made it this far, thank you for watching. Drop a comment below telling me which scorpion fact absolutely destroyed you the most. And if you haven't subscribed yet, now is the time. Hit that button, hit the bell, and we'll see you in the next one.